Hello guys, welcome back. So in this lecture, we are going to understand what is data structure, what are its types, why we need data structures, and why we have lots of data structures in the first place, right? So we are going to see like what is the reason why we have lots of data structures, lots of different type of data structures. Isn't there any data structure which we can learn, just one single data structure which can help us in all the scenarios? So we are going to discuss all those things in this video. Okay, so let's understand the definition first. Let me quickly zoom it a little bit. So a data structure is a way of organizing and storing data in computer so that it can be accessed and used efficiently. It refers to the logical mathematical representation of data as well as implementation in a computer program. Okay, so this is about definition. In simple words, you can say like data structure is a way of storing some data. Okay, we write an algorithm so that we can store the data in a structure in which we want, so that we can efficiently access it, we can add more data efficiently, we can remove data out of it from that structure very efficiently. Okay, this is all about efficiency. So we are going to build some sort of structure which can make our life easy to access or remove data from it. Okay, so that is all about data structure. That is why we use data structure. Okay, so data structure is basically categorized in two broad categories. Okay, so first one is linear data structures, the second one is the non-linear data structure. Okay, so let's have a look at them as well. So linear data structure, a data structure in which data elements are arranged sequentially or linearly. Okay, where each element is attached to the previous and next adjacent elements, it is called linear data structure. Okay, so in simple words, in linear data structures, the data which we used to add, they are attached with the previous data and the next data. So they have the idea of like which one is my previous data and which one is the next data. The best example for this is going to be queues. Okay, and you can say array as well. In array also we have the idea like current element what is the previous element of this one, what is the next element of this one in the arrays as well, right? Because all the elements are indexed. Okay, so the same way we have stacks and queues as well. We are going to see a visual representation of those as well, so don't worry. For now you just have to keep in mind like stacks, queues, arrays, these are all linear data structures in which we arrange the data, we store the data in a sequential manner. That's it, right? So the second category is non-linear data structure. Simple, we don't store the data in a sequential manner, we can randomly store the data wherever we want. That is all about non-linear data structure. You can go ahead with the definition as well, so let's read it. So data structure where the data elements are not placed sequentially or linearly are called non-linear data structure. Examples are trees and graphs. Again, we are going to discuss about all these things which are mentioned here in the future lectures, so don't worry about them. For now we just have to understand about the data structures in this lecture. Okay, what is data structure? In case in any interview, in any interviewer asks, you have learned about so many data structures, that's cool, but what is a data structure? Then you guys will have no answer. You guys will just simply smile, right? So that is why it is important to understand what is a data structure before actually learning about different types of data structures, right? So now, why we need data structures? Okay, so there are actually a couple of reasons why we need data structures, because in JavaScript also we already have some built-in data structures like arrays, objects, maps, sets, and you guys might have used it already, but you are not aware, I think, like these are data structures. Okay, so those are basically data structures because those are the ones which stores the data. If you think of it, array also is a data structure where we used to pass the data which gets stored in the array, right, in some sequence, right? So same way we have objects. In objects also we store the data in some structure, right? Now, why we need the data structures? So there are four reasons: because of its efficiency, flexibility, reusability, maintainability. Let's go with the each definition one by one. So before reading these things, let me give you a quick summary like what are these. Okay, so let's say you have written a code, okay, where you have to frequently add or remove data from the starting of the data, from the starting of the array or from the end of the array. You have to frequently add and remove the elements from it. So in that case, array will not be the good choice for you, right? Because if you think in array, if you remove the first data, it reindexes all the elements, right? So that is not an efficient solution. In that case, we should prefer queues, right, or linked list. Because in doubly linked list, if you add or remove the elements from the end or starting, it does not affect the rest of the elements index. Okay, so in that case, linked list can be a performant or can be a good choice if you have a data where you have to add and remove elements very frequently, right? So that is why we use data structures, so that we can make our code more efficient. Okay, so yeah, now let's talk about efficiency. Data structure allow for efficient storage and retrieval of data, which is important in applications where the performance is critical. Okay, so always you have to keep in mind, we concern about the performance only when we work with the large data set, right? For the small data, we don't even care about the performance. But in case of large data set, we have to care about the performance. Otherwise, a single second of lag can affect a lot in the application. That is why you can say, like, small startups, small companies don't worry about the performance, or like what we can say, performance sort of stuff in their application. They just want their feature to be built. Okay, they don't care about the performance, efficiency, and all those stuffs. But on the other hand, if you think of Google, they are very concerned of the performance, efficiency, maintainability, all these things, because they have a huge audience, they have a huge data set. Okay, so if they don't worry about the performance, then just think of it, you are searching something in Google and it takes 30 to 40 milliseconds, or we can say 2 to 3 seconds to load the results. So obviously you're going to get offended, you're going to get disappointed with the results, right? You simply won't wait for that much time in case if you are in rush to search something, right? So that is why large data set, in the case of large data set, we do have to worry about the efficiency. So in that case only the data structures comes into picture. Okay, so yeah, now let's talk about the flexibility. Data structures provide a flexible way to organize and store data, allowing easy modification and manipulation. Okay, so if we build a data structure, by the way, we are going to build a data structures from scratch, where we are going to write like, in, let's say, an example of linked list, right? So there we are going to write the push method, pop method, shift, unshift, index of, includes, all these methods from scratch for that particular data structure. Okay, so that we can easily access, we can easily modify, we can easily manipulate the data. Okay, so that is why flexibility is an important factor. Okay, so reusability, we write the data structure so that we can use it in different places, in different applications. Okay, so we don't have to write reusable code over and over again. Okay, so we just write one data structure which we can use in multiple scenarios, okay, in multiple places of the application, instead of writing duplicate codes, right? So maintaining a data structure is also easy over time. That is why maintainability is also considered as an important factor for writing a data structure. Okay, so these are the four factors why we need data structures. If you need the efficiency, flexibility, reusability, and maintainability, okay, so you have to go with the data structures. Otherwise you can use the existing features of anything. Okay, now the question you guys will ask is like, okay, that is fine, we have data structures, but isn't there any just one single data structure which we can learn and which can help us in all the different scenarios? So the answer is no. Okay, so you think of it like this: you purchased a bike. Okay, so you sure you can like roam across the countries with that bike? No, right? If you want to roam across the countries, then you have to go through the flight, you have to book a flight, then you can reach like cross border countries, right? So same way, for different scenarios we need different data structures. We don't have any such data structure which can excel in all the scenarios. So every data structure have its own excellence, we can say. Okay, so all the data structures excels in their own use cases. Okay, We can't say there is one single particular data structure which can perform fine, excellent in all the scenarios. That's not the case. That is why we have different data structures. So we have two examples here. So let's say you want to write a scheduler. Okay, so for that you should go for the binary heap. That is going to be the best option if you want to write a scheduler. Okay, and the other example is like if you want to do some web scraping from the nested HTML. In that case, you can pick up any tree data structure. So that is going to be a good option for you. Okay, so for web scraping, if you use binary heap, then that's not gonna be the good idea, right? So that is why for different use cases we have different data structures. Okay, so that was the answer of it, like why we have so many data structures. Now let's quickly visualize it, or in case if you want to like take a screenshot of it, you can take a screenshot of this one. You can pause the video and take a screenshot of this, and then you can take a screenshot of this one, and you can take a screenshot of this. I think this two you can take in single screenshot, right? Okay, so now let's visualize few of the data structures, and then we'll start discussing about them in detail from the next lecture onwards. Okay, so you again have to go into the visualalgo.net, and here in the first screen itself you will see we have couple of data structures, like we have binary heaps, we have binary search trees, we have graph structures, we have linked list. So let's click on the linked list. Okay, so I'll just give you a high level overview. Okay, so as you can see here, the data is arranged in sequence. Okay, so that is why they are linear data structures. Okay, so here as you can see, we have head, we have tail. This is a starting point, basically this is the end point. We have stack as well. This is also a linear data structure. Queue, linear data structure. Okay, doubly linked list, linear data structure. But we have these arrows. What are these arrows? Everything we are gonna understand in depth in upcoming videos. Okay, I'm not explaining you everything in this video, otherwise you will simply get overwhelmed. If I pick all these topics individually, if I explain them in detail in multiple parts, then you will grab them very easily. Okay, so there is a reason why I'm not explaining all the things in just one go. Okay, so yeah, these are the what to say linear data structures. Let's see some of the non-linear data structures. I don't know if I can go back. Let me see quickly. Yeah, I can go back. So let's see binary heap. Okay, so again I have to close it. Okay, so we have binary heap here. As you can see, the data structure is not linear, it is totally random data structure, right? Not random, but the data structure we are not storing any numbers in a sequential manner. Okay, so here we have 19, then 43, 48, 63, 24, 55, 43. So we are not storing data in a sequential manner. That is why they are called non-linear data structures. Okay, so this way we are going to see couple of data structures. We are going to build them from scratch in the upcoming videos. So yeah, there is a lot of great content coming down the road, so stay tuned. This is it for today's lecture. See you in the next one.